And I'd like to start this off. One of the things that we were asked to do for this part of the symposium on TR is really try and better understand what should be the ideal way to image intraprocedurally, as some of us at times can be challenged by, if we can't see what we're doing, it's hard to do the right thing here. So I'd like to go down the line for people that have presented about your particular devices. Tell us a little bit, how do you do the procedure from an imaging standpoint? Malcolm.
So Forma is perhaps, I think it's a little bit different than the other, some of the other devices, is that you don't need to see the leaflets as well and the annulus as well, and you're really focused more on imaging the anchor deployment. So the TEE images are key, and I believe you use transgastric mostly, and I think that's really what we rely on the most, and also the CT pre-procedural planning. So in that way, it's nice for patients who don't have good imaging of the leaflets or the annulus because of shadowing from a aortic or a mitral prosthesis. If they have good transgastric images, then Forma might be a good option for those patients.
And is there any patients that you would exclude if, like, you don't have good, they've had prior stomach surgery or something, that you can't get a good transgastric TE views?
Yeah, definitely, and I think Becky probably has, as the core lab, she probably has excluded some patients based on that. I mean, if you can't see the anchor point very well, then and you can't be confident that the anchor is going to be deployed, then you could consider ICE in that circumstance. We really haven't done that ourselves with ICE at this point.
Yeah, no, that's exactly right. I mean, as with most of these devices, there's an imaging protocol that's required for screening, and apical views at the intended point of anchoring is required, for us to be able to be sure we can, help with the procedure. I mean, I think that even with the imaging, there comes a moment when you're implanting the anchor that we can't see, and so. After that, it's just making sure once the anchor is deployed that we feel it's actually attached correctly and through the entire RV myocardium. So we really kind of want it through and through, and then the anchors bend backwards and come back in, and haven't really seen any bleeding complications. But before you deploy the actual spacer, you have an opportunity to take the anchor out if you don't like it. So it's key for the imaging to do that. But otherwise, we've relied heavily on TEE and 3D. But I know, when we did the Navigate device, and all of our Navigate experience has been with the most advanced imaging machines that you can get your hands on with real-time multiplanar 3D imaging. So it's, again, able to manipulate the images because the tricuspid valve is so canted. Just for anatomic reasons from our TEE probe, and so being able to straighten it out and see all. For the Navigate, it's a really short device. It's only a 2-centimeter tall device, and so the septal leaflet is offset by another centimeter, so you don't even have an annular plane. The annular plane itself is offset, and so it's a fairly narrow landing zone if you want to make sure you get yourself in the end.
And so, Becky, how do you deal with those patients that have concomitant aortic valve disease and a bioprosthetic or a mechanical in the aortic position, trying from those mid-esophageal views to get that plane? It almost always seems like you have tremendous shadowing from your aortic bioprosthetic.
Yeah, that's why we found the distal esophageal view. And the distal esophageal just is right before the GE junction, and you'll feel the pressure there. The tricuspid is sitting on the diaphragm, so the further you put your probe in, the closer you get to your tricuspid valve. And that's the beauty of the whole thing. And so we've, really used extensively what's called the deep esophageal view, which we hope to add to our TE guidelines in order to image the tricuspid valve. And even the shallow transgastrics, which are now with multiplanar reconstruction, you can reconstruct it as a long axis view if you want. From a transgastric. So anything that gives you the best imaging possible, you then use that to reconstruct your two-dimensional imaging from 3D.
Okay. Jason, you want to talk to us about millipede on the tricuspid?
Yeah, I mean, so the millipede, I didn't really talk because there's only been 2 patients and they've both been surgically implanted. And I think, that will be the next sort of development phase for millipede. But right now, the program's very focused on the mitral. But you could see how it could be adapted to the tricuspid, same idea, you have ICE. To talk about imaging, I think ICE is really, for tricuspid, is going to enable us to do more patients. I think the patients we're doing now are the ones that we have good TE windows on, and so they make it to the cath lab table and we're able to do the procedure. My sense is there's a lot of patients that never make it into the trials that we see because they've been screened and their TE windows for tricuspid are just not very good. We've certainly used ICE adjunctively during our tricuspid clipping procedures in cases where we weren't entirely certain that we saw insertion on both leaflets. We'll put an ICE catheter in the right atrium and look at that. But it does seem to me that ICE, and particularly the 3D ICE, will really enable a lot of these procedures.
So Paul, for tricuspid clipping, what's the best way of imaging and also for the future?
Well, I think the easiest way is to get images like what Becky's shown with the beautiful RV inflow and combining that with the transgastric images like I showed, where you can see the leaflets. Like Pascal and others, leaflet insertion is key. And if you can't see the leaflets, it makes it just virtually impossible. And we have to be more meticulous about it with tricuspid versus mitral because the leaflets are thinner, and in my view, they don't tolerate poor insertion as well as a mitral would do. And that's simply because they're thinner, and they're less robust, and they're more susceptible to tears and SLDAs. And so to me, right now, it's TE, especially the transgastric view. But I think I echo what Jason has said. The ICE, I think, is going to be a real nice benefit, and I would love to see that used more and more to assess leaflet insertion.
So I'm curious, I've always struggled with standard ICE or any ICE on the tricuspid side, in part because I think the standard 2D, doesn't have the multiplane capability. And then the 3D just doesn't have really good temporal or spatial resolution of the currently available marketed ICE catheter.
Right, so right now, you're right. We don't use it for grasping or any of that stuff, but it's only after we've grasped with TE, because you can, in a single plane view, see at least one arm, one leaflet at a time. So you could see, the septal leaflet, septal arm, anterior leaflet, but you can't. It's very hard to see both leaflets and both arms at the same time on ICE. You're right.
Yeah, I think you need TE for the arm alignment. It's very critical. I think pinwheeling is going to be just as important or even more important for
You want to explain what
tricuspid.
pinwheeling is to everybody?
Well, pinwheeling is simply when the leaflet coaptation plane is not grasped perpendicular. And so if your arms are off by a certain amount of degrees, then you've grabbed the pair of leaflets not perpendicular, and as a result, when you close, the leaflets can turn, and then you lose the coaptation that you're trying to recreate with, that nature all gave us. They gave us 3 to 5 millimeters of coaptation length. You lose that because of that twisting. And so I think the pinwheeling is going to be even more because the coaptation plane is even harder to visualize with tricuspid, and it's less forgiving because of that. So.
Yeah.
Yes, I think our hope is that, there's some new 3D ICE catheters that are being developed, so that have full volume, 90 by 90 volumes, very high temporal resolution and spatial resolution. And they're matrix probes versus the halo design of the current probe.
Can I ask you a question about that?
Yeah.
So, Becky, you've had your hands on these new 3D ICE, but it's coming from the groin, so how are you going to scrub in, are you going to get in there, and how are we going to do that?
No, that's a great question. Not at Columbia, but at a former institution that was at, the echocardiographer still came in and operated the ICE catheter. So I think that it will be, because it just makes it faster, because you've got one operator on one side, the imager is going to be on the patient's left side, and so it makes it much smoother if you've got two operators in there. But I think that that's an algorithm that every site will have to decide on. You're a very skilled ICE, probe manipulator. So, there's some, I think, interventionalists that will be able to do it all, or have a second interventionalist controlling, controlling control the.
So
Yeah,
Scott and I were talking about the 3D ICE because we use it for Cardioband, and it's easy to use when you get good images, I guess, because there's not much manipulation. So it's not much about being a good ice person, even less so than in 2D ice, because basically I mean, right, it has it sees more, so basically it's just very minute changes. But it's very crowded over there, and I guess if somebody else was operating, they'd have to be on the other side. I mean, there's two of us now, and we're like under each other and over each other trying to, it would be great if they could develop it from IJ.
Right, or even better yet, I think the idea that you use with a millipede, where you integrate it into
Or
the delivery
integrate it.
system, so it is it's fixed, your
your
location where you're
View
trying to
is
see.
always unobstructed.
Yes.
Yeah, exactly, because that's a huge problem, especially in the tricuspid. You have so many, a lot of times you have pacemaker leads and other valves, bioprosthetic or mechanical or whatever, and the shadowing is horrible, and then they all interact with each other, and it's still a big
Right.
mess.
So, all right, Molly, for forecheck tricinch, how do you do the intraprocedural imaging?
Yeah, so the intraprocedural imaging is pretty easy. It's all fluoro-guided and TEE, basically. So you don't need, there's no leaflet insertion or anything, so you don't need the imaging from like ICE or anything like that. You just need good TEE images to see tricuspid, decreasing. So it's kind of an easy one.
Great. So for TTVR, Vinny, even if we're talking not for a device for a native implant, meaning like, say, valve and ring, valve and valve on the tricuspid side of things, can you get by with just fluoro alone? What's the role or the value for anything else?
I think you're right. I think a lot of the imaging which we are discussing, I think is going to be device specific as well. For example, maybe for annular placed device, you need ICE, but for leaflet-based device, you need a bit more definition. So similarly for this, for example, for Navigate, you need a bit more accurate imaging because it's deployed from ventricle to the atrium. But for Intrepid, the brim is so beautifully visible that you could probably position it from atrium to the ventricle. But as it happens at present, you don't want to try it in first 10 or 15 patients. So we definitely will use imaging in these patients. Wall-in-wall is simpler because we already have some visualization of the annulus. So there are some new things which are coming through which will allow us to visualize mark the annulus beforehand and then do the procedure later. So I think we'll see some things by next meeting, I hope, which will allow us to get that better.
Well, let me end this by one last question to you, Vinny. We're all talking about imaging for positioning. What about imaging for can you get to where you need to go? Meaning, you talked about a delivery system for Navigate, which is 35 French, which is orders of magnitude bigger than most people have experience with. What is our upper limit of what can we get through the SVC or IV femoral veins, and how do we figure that out?
So I think we know in practice now that 28 French is reasonable. The delivery systems bigger than that have always had some problems in terms of either groin issues at access points or even thrombosis. And my feeling is that unlike open heart surgery where we put bigger cannulae through, but the patients are fully heparinized for a long time, here I think when the delivery system, especially the big size delivery systems go through, they tend to either damage the intima and give rise to some thrombosis issues. I think 28 to 30 French will be reasonable. And as the delivery systems get more flexible, maybe the guide catheter which we use can become something like E-sheath. And I think that's the way to go forward because what we need is a good access point to get to the heart, but which is collapsible. And then we put in a guide, we eliminate the need of guide catheter for flexion, etc. So I think that's what hopefully will give us a safer approach.
Right. Before we totally end this session, any questions from our colleagues in the audience or other questions from my colleagues on the panel?
That's great.
Neither do we, so go ahead.
Just want your thoughts, Vinny, on and the rest of the panel quickly about, when we replace mitral valves surgically, a lot of times for ischemic MR, we're downsizing the mitral valve to some extent because some of us think that making the base smaller will actually help ventricular function. Yet all the transcatheter devices, particularly those in the tricuspid valve now, are using an outward approach that actually might increase the annular diameter. So do you think that's going to have any lasting effect on the tricuspid or RV function, even though you're eliminating TR? I worry about that a lot.
No, I completely agree. I think that's why devices like Navigate and maybe even Evoke, where the fixation is around the leaflet. So what you're essentially doing is drawing those curtains from both sides to fit it in the middle. Maybe that will eliminate this problem. In Navigate, our oversizing algorithm is now 0 or -5. So we are hoping that actually with the preload changing, it will
Do you see evidence that the annulus gets smaller?
Yeah, I think that's what we think is with preload going down, the remodeling will be quicker. I think initially we probably used oversized devices by nature of the tower learning, which is not good for these patients.
Excellent.
All right, unless there's any other thoughts, I want to thank all of my colleagues that were speaking and all of you for joining us. We're closing this session.